Consider the following example. Here we are given a third order differential equation and we are asked to find the state space representation of this equation. Now, the easiest way I prefer doing an equation like this, I would like to change your dx dt into like x dot, x double dot, etc., etc. So just make it, you can work on it straight away the way it is, but let me change this a little bit, then we can go further. So here we have x triple dot plus 6x dot dot plus 4x dot plus 9x is equal to your input u of t. Now, because with a state space we want to convert this third order differential equation into a set of first order differential equations, and what we can do is we need to change our variables. For example, it's always easier to start from this side. If you let this one is equal to x1, then we say this is x2 and this one will be x3. Then the highest order, you do not assign it a variable, so you just leave it. Now we are going to, what we have now is, we said our x1 is equal to x, then x2 is equal to x dot, and we say our x3 is equal to x dot dot. So what I've just written this information that we wrote here and I put it there so that we can see which one was assigned to what. Now, these are our state variables. So we have x1 is our state variable, x2 is our state variable, x3 is our state variable. Now we need to find our equivalent derivative of our state variable. So what I'm going to write is, I'm going to write x1, our state variable, and its derivative. It's equal to something. I don't know yet. I'm going to work on it. We're going to have x2 and its derivative. We're going to have x3 and its derivative. Now, when we look at this equation, we say that x1 was x. So the easiest way to find our x1 dot is, I'm going to use a different color so that we say, if I put x1 dot here, this means I'll put a dot there, and 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 I'll put a dot there. You can see now this, we have x1 dot is equal to x dot, x2 dot is equal to x dot dot, x3 dot is equal to x dot dot dot. Okay, so we are going to rewrite this. We say x1 dot is equal to x dot, and we say that x dot is also here, x dot is also x2, and meaning that we can also say, oh okay, x dot is also equal to x2. Okay, then we leave it. x2 dot, we have x2 dot is this one. Okay, x2 dot is equal to x dot dot. So x dot dot, we know, we can see from here. Let me just get the highlighter. From here, x dot dot is equal to x3. So we just write x3. This is x3. The next one we have x3 dot. x3 dot is this one. Okay, so x3 dot is equal to x dot dot dot, which is equal to, now this is not here, but what we can do is we can take this whole equation and move it on this side, so that we are going to have x dot 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 is equal to u of t minus x dot dot minus 4x dot minus 4x. So we are going to rewrite this as, it's equal to, we have u of t, we move everything on the other side, minus 6. Let me start from the smallest one. Let me start from the 9, just then we increase the order. So minus 9x. Now 9x is assigned x1, so we can write 9x1 minus, the next one is 4x dot. X dot is x2, so we write 4x2 minus 6x dot dot. X dot dot is x3, so minus 6x3. Okay, now we can pull out our state equations, because now remember, this is our 3 state equations. Okay, and what I can do, we can say, okay, we are going to have our state equation x1 dot x2 dot. Now we have to write this into a matrix format. X3 dot, it's equal to, you'll have a box somewhere there, it's equal to something, times our state variable that we assigned this equation to, plus some input, times, I think we had u of t. We had a u of t there. So let me use a red color so that we see where things are. So now x1 is equal to x2. Let me put in our state variable first. We had x1, x2, x3. So x1 is equal to, we are looking at this area here, the first one, x1 dot is equal to x2. So this means x1 dot here times x1 is 0. x1 dot times x2. All right, here we have a 1. I mean x1 dot is equal to x1 times 0, meaning that we don't have anything, times x2, we have equal sign here, and x3, it's not in that column, and we just put a 0 there. Now we move on to x2. x2, we can see x2 dot is equal to x3. So there's nothing on x1, there's nothing on x2, but there's something on x3. Then we come to the next one, which is x3 dot. x3 dot for x1, x1 we have minus 9. So we have minus 9 there. x2 we have minus 4. x3 we have minus 6. U of t here, there is nothing on x1, there is nothing on x2, but there is something on x1. Now, this is in our state representation form. But most of the time you will be given as well your output equation. And assuming that our output equation maybe is equal to x3, let's say assuming that y is equal to x3, what we are going to do is we are going to write our output equation. You are going to have a box for output equation, which will be something here times our state equation: x1, x2, and x3. And remember, the format that we want is x dot is equal to ax plus bu, and y is equal to cx plus du. Okay, so if here we are going to have our y is equal to x3, it means that at x1 there is a 0 here, there is nothing. x2 there is a 0, x3 there is a 1. If y was equal to x2, then we are going to have y will be x1, x2, x3, so you will have 0, 1, and 0. Okay, so now this is in our standard form, because what we have is we have our x dot here. This is our A matrix. This is x plus b and u there. This is our y matrix. This is our C matrix, and this is our state variable, and plus the du. Normally du we assume it's equal to 0 because the du is a feed forward. And let's draw a diagram so that you can see where these things are if you had to simulate this in Simulink. Let's write our equations again. It will be x dot is equal to ax plus bu, and y is equal to cx plus du. And if you have to draw this in Simulink, you are going to have a box there, a summation block, another box there, another box there. I will have another one there, and another box there. So you are going to have an input there, another input, output into that, another one, and we'll have a summation block. You have an input there, and this one is a feed forward which fits into that block, and this is our output. This is your input u of t. This is matrix B, and here you have a derivative that is going in, and you integrate it, you get an x out. You have a matrix, C matrix, and the D matrix, and also you are adding them here. As you can see, if you have to start, for example, you have x here times a, that will give you ax, plus you have b times u plus bu of t. All right, then together the summation of that and that, the output should give you an x dot, which is this one. All right, fed in through an integrator, because in Simulink we have this integrator, and we have as well another line which you have your output y is equal to, you have c times x is cx, and your summation block plus d times u is du. Okay, let me look at another one more example. Okay, here we have another example, and we want to write this ODE into a state space representation. And again, what we want to do is we want to rewrite this into a different format. But if you are comfortable in converting this directly, which is fine, but I prefer writing it in a different format. So we have x dot 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 plus 3, y dot 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 plus 3y dot dot plus 2y dot minus 4y is equal to e to the minus t. Now we need to change variables, and as we can see, we start from here. Let this be x1, let this be x2, let this be x3, and what we have is we assigned x1 is equal to y, we said x2 is equal to y dot, and we also assigned x3 to be y dot dot. So those are our state variable. Now we need to write the derivative of each state variable. So we can say x1 dot is equal to, let me just do it in a red pen again. If I put a dot there, I'll put a dot there, I'll put a dot there, another dot there, and there. Okay, I hope that is visible. So now we said x1 is equal to y dot, and we said y dot was x2 from here. Okay, y dot is x2, so we have x2 here. The next one we need x2 dot. x2 dot is equal to y double dot. Y double dot, we assigned x3 here, which is x3. And the next one is x3 dot. x3 dot is equal to y dot dot dot, which is equal to, is not assigned, but we can work it out by taking this whole equation to this side. So which means we have e to the minus t minus, okay, we're gonna have plus 4. Now 4y is x1, so it will be 4x1 minus 2y dot. Y dot is x2, so we're gonna have minus 2x2 minus 3y dot dot, which is assigned x3, so we'll have 3x3. From there, since we have our state equation, we can write it in a standard form. So what we have is x1 dot, x2 dot, and x3 dot, and times the x state variable, which are x1, x2, x3, plus our input, which is going to be something in there, times e to the minus t. Okay, so x1 dot is equal to x2. So at x1 is 0, x2 is 1, x3 will be 0. x2 dot is x3. So x1 is 0, x2 is 0, x3 is 1. Next one is x3 dot. So x3 dot at x1 we have 4. x2 we have minus 2. x3 we have minus 3. And plus e to the minus t, meaning that on x1 we have 0, 0, and 1 here. Again, our output is not given. Our output will always be given. And for example, if we assume now here our output y to be x1, if output is x1, then we are going to have y is equal to something times x1, x2, x3. So, and here we are going to have, since it's x1, it will be 1, 0, 0. And this is our standard form. I will do one more example, and I hope this is clear before we start looking at equations for mass spring dampers, electrical circuit, translational rotational systems, etc. Okay, so here's another example, and we want to write this equation in state space form. Again, I'm going to rewrite this equation. We have 3y dot 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 plus 2y dot dot plus 4y dot is equal to 5u. And I'm going to assign, now as you can see, normally we say x1 is x, but now I don't have x or y here, but I'm still going to assign it, assuming that it's somewhere there, so that I'll have x1, x2, x3. Okay, and x4 will be somewhere there, even though it's not there. I can just imagine as if it's there. That way it's easier for me to work with equations. And let's say by changing of variable, we say x1 is equal to y. We know y is not in this equation, but it's fine. x2 is equal to y dot, which we have. x3 is equal to y dot dot, which we have. And x4 is equal to y triple dot, which is not there, but it's still fine. Next, I want to write the derivatives of these equations. So again, let me use my red color to put in our derivatives. If I differentiate that, and that, and that, and that. Okay, so just make it a bit bigger so that you can see. This is, now we can write x1 dot is equal to y dot, and y dot is equal to, this is x2, y dot is equal to x2. Next one, we have x2 dot. x2 dot is equal to y dot dot, and y dot dot is equal to x3. x3 dot is equal to y triple dot, which is equal to x4, and x4 dot is equal to y dot 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 dot, which is equal to, now what we do is we take this whole equation on this side, but we need, because remember what we want is this is equal to something, so we have to divide the entire equation by 3. Okay, so what we are going to have is 5 over 3u minus 4 over 3x2 minus 2 over 3x3. Okay, now this system is ready to be written into our state space form, which is our standard form. So we are going to have x1 dot, x2 dot, x3 dot, x4 dot is equal to our big A matrix times our state variable, which is x1, x2, x3, x4, plus our input matrix times u of t. So x1 dot is x2. So you're going to have 0, 1, 0, 0. x2 dot is equal to x3. So we are going to have 0, 0, 1, 0. x3 dot is equal to x4. So we are going to have 0, 0, 0, 1. And x4 dot is equal to our entire equation. So for x1, we don't have x1 in there, so there is a 0. x2 is minus 4 over 3. x3 is minus 2 over 3. x4, there is nothing, so it's a 0. Okay? And our input equation, we have 0, 0, 0, and 5 over 3. All right? And our output matrix, again, here is not given, and we can choose it to be, let's say maybe y is equal to x4. All right? If y is x4, then we are going to have y will be x1, x2, x3, x4. So you're going to have 0, 0, 0, 1. Okay? Now, if y, for example, is say to be, maybe you want two outputs, because it is possible to have two outputs. Maybe y is equal to x1 and x4. Okay? So what you are going to have, you will have something like this. You're going to have y1 and you're going to have y2. Okay? And this one will be in this big box, which will have x1, x2, x3, x4. And you can have y1 is x1, which is 1, 0, 0, 0, and this is going to be 0, 0, 0, 1, etc. Okay? And you can also, you can write it in a single column format also, such that you have 1, 0, 0, 1, whereby you have x1, x2, x3, x4, etc., etc. Okay?